Man, I've been working on this problem for like 5 days now, Tim. You think you can help me out?
I think I got it.
Oh, is the camera on? Yo, Tim, the camera's on.
What?
The camera's on, dude.
Oh.
My name's Kevin. This is my partner, Tim. And our third partner should be around here somewhere.
Try.
Where'd you go?
Woo! Right here, baby. Okay, so let's get out of business. No more fooling around. Our project's on strain gauge / thermistor. Well, mostly thermistor, so that strain gauge wasn't working like we presented earlier. And yeah, we're gonna get out of the business and we'll be showing you what's going down for you. Set up. Kevin, this way.
Oh, my bad. Oh, what where those two went? Hey guys, we're going to talk about our objectives. You guys probably know our first main objective was to get a sensor working with a computer. And then we had to take it a step further and get it working with a LET. And what a LET means, it means a lead emitting diode. And hold on guys, my phone's here. Hello? Hello, Mom? Yeah, I'll get the crab rangoons. Alright, sorry guys. Mom. But this is our negative and positive side of the LED. And the LED actually has an internal variable resistance. And depending on how much voltage is put through, determines the brightness of the LED. And for our project, we had a constant 5 volts going through the LED. So there was no change in brightness or anything. There was a constant, it was just light on and light off. And because the LED was fed by a constant voltage, we took this to our advantage. And we had 3 LEDs light up based on the temperature threshold that was written in our coding. And as the temperature, so basically what it means is, as the temperature increases, the LEDs lit up. And when the thermostat reaches its maximum value, all the LEDs will light up. And next we're going to take it on to schematics, and I'm going to hand it off to Tim.
Where'd those guys go? Oh. Hold on. Alright, we got 5 volts from the Arduino in our circuit coming through this 10 kilo ohm resistor. The 10 kilo ohm resistor, we had to mess around with a little bit. If the values were too small, then the numbers would jump too quick for us to see. And if the value was too great, then it really didn't change at all. So we got our 10K, and it goes down to our thermistor, which is a variable resistance. Depending on how much heat there is, that's how much resistance will be. Right here, this node right here is an analog pin on the Arduino, and that's just so we get big values on the computer. Excuse me. 2, 3, 4. All right. These are our digital pins on the Arduino. There's the resistors here, kind of arbitrary, don't really matter. We got 3 resistors, 1 green, red, blue. The reason we did this is to show I got 1 value, I think it was 550. This light would turn on, which is about 76 degrees, and once it got to, I think it was 5, I don't know about the sensor values, but this was 82 degrees and this was 86 degrees. So at each one of those degrees, this one would light up, then these 2 would light up, and then all 3 would light up at our maximum 86 degrees. And I just go down the ground, and that's about it. I'll hand it over to Chirag to explain the code.
Hey guys, I'm back. Okay, so what we got here is we got the Arduino, which is this green thing right here. And then this is our circuit. Our circuit is based on a schematic we showed you earlier. We have 2 pins going out here, which is a 5 volt and the ground, which connects to the bus line right here, and the 5 volt goes to the thermistor. The thermistor is actually this orange little variable resistor right here, if you can take a good look at that. And it's connected to a 10 kilo ohm resistor like we showed in the schematic. And we have our 3 LEDs. It's green, red, and this is actually a blue one. And they're connected to a really small resistance because we wanted this to be as bright as possible, basically. The green one's the lowest temperature. This one's the middle, and this one's basically the highest temperature. And we're going to show you that in demonstration in a little bit.
Alright, so we're just going to demonstrate the LEDs for you right now. Room temperature right now is about 72.6 degrees. But as I put my hand on the thermistor, the green will start to light, then red, and then blue. The green temperature right now, the green LED is actually 78 degrees. The red LED is 82 degrees, and the blue is 86. And as the resistance increases, the temperature will increase, and the LED will light up. Perfect. Yeah, let go. Let go.
Oh, where the hell are the guys? Alright, whatever. Whoa, this is gigantic. Planetesimal. Awesome! Alright, let's bring it up. See what we got today. Bam, bam. Alright, so this is basically our code we used for our sensor. Towards the beginning, we have the initialization of the variables, and then underneath, where the void loop starts, is where our code actually begins. The sensor value equal analog read means basically just the sensor value is going to read whatever the analog input is, and analog input is in 124 levels, 1024 levels, sorry, and each level is 5 millivolts in change. And this double temp is an initialization of what's under it. And this coding right here is we picked up off the internet. What it does is basically takes the analog input and converts it so we can have an output in degrees Fahrenheit. And then if you scroll down a little more, we can see the serial print is just going to print out whatever the temperature is at that time. And then we scroll down a little more, we see that this if-else statement we have is where our LEDs actually comes into play. The first one is if sensor value is greater than 0 and less than 510. 510 is referring to the room temperature. We calculated that 510 was exactly 72.6 degrees, which was the room temperature. So if it's lower than room temperature, that means if it's lower than room temperature and greater than 0, then all the LEDs are off, which means low. So 2, 3, and 4 are low, which means they're off. And then you scroll down a little more, the else if statement here says sensor value greater than 510 and less than 530, which was between 72.6 degrees and 76.4 degrees, which means that once it passed 76.4 degrees, it would the LED 2 would go high, which was a green one we showed you, and all the other 2 went off. And if you scroll a little more, you have the else if statement, which said sensor value greater than 530 and lower than 550, which basically meant it's between 56.4 degrees and 82.4 degrees. And that will give you a high on 2, which means the green and the red will go off, and the blue will stay low. It means it's not going to go off. And then you scroll a little more, and then I just talked about else, meaning that if it's anything but those, it just all together are going to light up. And then as you can see, high on all the 2, 3, and 4, which means that all 4 of the LEDs will go on. And this basically is our LED. And now I gotta find those guys. I think they said room 4 something. What was it?
Go.
Where the hell are these guys, man? Jeez. I can't believe I gotta look for these rods.
Where are these guys?
Come on, guys, where'd you guys go? It's not funny anymore. Come on, guys. Hey, Tim, what's going on, buddy? Hey, high five.
Where's Ciruts?
Yeah, I don't know where he is.
Oh,
Yeah,
yeah.
where'd he go?
Woo! Right here! Yeah, you guys expect. Oh, whatever. Okay. Alright, so this concludes our project. Hope you guys liked it. If you have any questions, we'll be answering in class.
And this will be uploaded to Wikispace. So.
That's right, Wikispace will be on there.
So you guys can watch it all the time.
All the time!
Right.
Over now.